All right. Today we're going to find common units or number of units to compare two fractions. So right here I've displayed 3/4. 1, 2, 3, 4. My denominator is 4. And I've shaded in 1, 2, 3 of them. So I've displayed 3/4. And over here I've displayed 1, 2, 3, 4, 5 total. 5 total. And 1, 2, 3, 4. 4 shaded in. Now what do we notice about these two fractions? I notice that when I look at the numerator and the denominator, I see that they are both 1 away from 1 whole. Do I have like denominators? So when looking at the denominators, are those two common denominators? Which means, is 4 the same as 5, and is 5 the same as 4? Hopefully your answer was no. So we're going to go here, we're going to zoom in on 3/4 a little bit. I have 3/4, and I want to find an equivalent fraction to 3/4. But the denominator needs to be both a multiple of 4 and a multiple of 5. Now, a very good way of finding your common denominators is to multiply one denominator by the other. So here we're messing with 3/4. So I'm going to multiply this 4 by 5. 4 times 5 equals 20. And since I multiplied the denominator by 5, I need to multiply the numerator by 5. 3 times 5 is 15. Now, seeing that I multiplied them by 5, I am going to partition this into fifths. And we're going to see if this area model will now match what I have written here. So let's count our total units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 total units. Good. How many of them are shaded in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. All right. So now I've shown in an area model, as well as a multiplication sentence, that 3/4 equals 15/20. So here I have my 4/5, and I want to find a fraction equivalent to 4/5 where my denominator is both a multiple of 4 and a multiple of 5. Now that trick that I had mentioned where if you're finding common denominators, multiplying one denominator by the other is a good way. So when we did 3/4, we multiplied this 4 by 5. Now we're looking at 4/5, so we're going to multiply that 5 by 4. Which means that our total units are going to be multiplied by 4. So go ahead and partition this into fourths. How many total units do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 5 times 4 equals 20. Now, since I multiplied the total number of units by 4, I'm going to multiply the shaded number of units by 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4 times 4 equals 16. Now before we move on, what is my unit fraction here? Remember that the phrase unit means just one. So if I took out just one of these, what is this right there? 1/20th. So I've used those units to count up to 16. When we go back up to here, we found that 3/4 is equivalent to 15/20. And we found that 4/5 is equivalent to 16/20. In the last video, I talked about comparing peaches to peaches. Before this, we had a peach here and an apple here. Well, that didn't help us at all, but now we're dealing with just peaches, 20. And 20, common denominators. Which has more peaches, 3/4 or 4/5? Which is the greater fraction? Well, I know that 16 is greater than 15, so 3/4 is less than 4/5. And we use the skill of finding common denominators to solve our problem. Now here in this next part, we're going to compare 5/3 to 7/4. And what do we notice about these two fractions? I notice that they are both greater than 1 whole. So we're going to make a number bond. We're going to find out just how much greater than 1 whole they are. So we're going to make a number bond for 5/3 and a number bond for 7/4. Now when we make number bonds, we partition into 1 whole first. So how many thirds equal 1 whole? If I had something into thirds, how many of these equal 1 whole? 1, 2, 3. I've shaded in the whole thing. I've shaded in 3. 3 plus what? 3 plus what equals 5? 2. Excellent. So there's 5/3 in a number bond. Now we're going to do the same thing with fourths. How many fourths equal 1 whole? Well, if I had something partitioned into fourths, I'd shade in 1, 2, 3, 4 to equal the entire thing. So how many fourths equal 1 whole? 4. When the numerator matches the denominator, that equals 1 whole. Now our problem is, how many are left over? 4/4 plus how many fourths equals 7/4? 4 plus what equals 7? 4 plus 3. So in 5/3, just looking at this over here, in 5/3, how many 1 wholes do we have? This one, right here, just 1. So we have 1 whole, and how many left over? 2/3. In 7/4, how many 1 wholes do we have? Just this one right here. We just have 1. And how many left over? 3/4. So they both have 1 whole. So they're both greater than 1 whole. What we need to compare is 3/4 and 2/3. We're going to do that using a tape diagram. Up here, we're going to show 3/4, and down here we're going to show 2/3. thirds, and we're going to use this tape diagram to show which one is greater. If I shade in 1, 2, 3/4, and I shade in 1, 2/3, which one wins? 3/4. Now, I agree that they are both one away from one whole. However, you remember that the smaller the denominator, the larger the pieces. So here we have two big pieces, which is impressive. And here we have three small pieces, which is not as impressive in my mind. However, if we look at it from the opposite end, they are one away from one whole. Well, this is one big piece away from one whole, and this is one small piece away from one whole. So definitely the size of these pieces make the determination. So if we were comparing 5/3 to 7/4, 5/3 is less than 7/4. Or 1 2/3 is less than 1 3/4. Now here we're going to use the same situation to compare 3/5 and 8/12. But here, I don't want to find a common denominator by partitioning it into so many pieces. So I'm going to use multiplication for this. Now we had talked about the easiest way to find a common denominator. So we're going to find a common denominator. A multiple of 5 that is also a multiple of 12. So here, we're going to use multiplication. We're going to times 3/5 by something, and we're going to get an equivalent fraction. Well, before I had said that the easiest way to find an equivalent fraction is to multiply one denominator by the other. So my denominator here is 5. I'm going to multiply it by 12. Since I multiply that 5 by 12, I'm going to multiply this 3 by 12. Start with 5. 5 times 12 equals 60. And 3 times 12 equals 36. So 3/5 is equivalent to 36/60ths. Down here, I would need to find an equivalent fraction to 8/12 using the denominator. So I need to find a denominator, a multiple of 12 that is also a multiple of 5. We're going to use that skill. Our brain's always looking for an easy way. This is the safest pattern. To find this, I'm going to multiply by the opposite denominator. So I'm going to multiply this 12 by 5. Since I multiplied that 12 by 5, I'm going to multiply the 8 by 5. Well, we just found out that 5 times 12 is 60, so 12 times 5 is 60. 8 times 5 equals 40. So here, we're not really comparing 3/5 and 8/12. We're actually comparing 36/60ths to 40/60ths. Now, back to peaches, because peaches are great. Here we have peaches. We have 36 peaches. Here we have 40 peaches. Which is greater? 36/60ths or 40/60ths? 36/60ths is less than 40/60ths, which means that 3/5 is less than 8/12. We use the power of finding a common denominator to solve two fractions with unlike denominators.